Hello. I'm going to remember to unmute the mic. Welcome, everybody. We're just getting started here with the new microphone. And everybody who was here last week, that was fantastic. I finally got around to getting a Discord, so feel free to jump in there. It's in the channel page, so you can see that down below. Last week we had a lot of fun building a Steam Deck. We managed to wire it up to a whole bunch of custom commands using the Linux event interface, and that was kind of cool. I didn't wire it up today because I had a lot of fun with the hardware that we're going to be dealing with. And hardware is always fun, let me tell you. But there is a... I'll be posting the code for that, and I'll drop a link down there below as well, in case you missed that. So this week, what are we doing? We're going to deal with infinite volume knobs. So normal volume knobs, which are quite boring because they have limits. They go all the way to the left, and that's 0, and then it sort of stops. It tells you, no, that's as far as you're going. Or they go all the way to the right, and that has the, that only goes to 10, and sometimes you want to go to 11. Now, when we're going to be building, we might even go beyond that today. So when we're going to be building a infinite volume knob, what we're not going to do is use the same piece of technology. So that's what's built into a normal volume knob is it's basically a variable resistor. So as you turn it, the resistance goes up, you turn it, and then you turn it down, and the resistance go down, it reads that, and it goes, okay, this is what volume you want. Or back in the day, it actually just directly limited how much output was coming to the speakers. So this is a little bit different. This is a rotary encoder. So these are the kinds that you might have seen in cars or modern equipment that has that kind of nice clicky sound, and it just sort of goes forever. You can just keep turning it, or you can turn it all the way back and whatever, that they're a little bit trickier because there's no resistance. They work on a slightly different technology. So we're going to cover that in a little bit. Basically what we're going to do, since they don't have ends, there's no start and end to a rotary encoder, we're gonna just kind of say, well, wherever the program starts up, that's your starting value, and we're gonna keep track of how much left we go and how much right we go. We're gonna deal with that on a we'll get to that in a little bit. So without further ado, I would like to invite you to this session.
So you're telling me that instead of writing code myself, I could watch some guy write code?
Right. Well, thank you for that. So we're going to come over here to the whiteboard for a moment and figure out what we're going to do. So this is a little bit different than what we've done before, because this time we're going to be dealing with actual hardware. So let me tell you a moment about that. So this is we're just getting started here. This is where we are, and we're going to be doing infinite knobs. So this is using a technology called a rotary encoder. Now, the way we're going to deal with that is we're basically going to take that rotary encoder, which is a nice little device. It's going to be coming out here, and you have your little encoder logic, and then that's hooked up, and then we have that's usually sitting on a board, and that board is the standard piece of PCB, and coming out the end of it is typically 3, sometimes 5 pins. We're going to take these pins and we're going to hook them up to a very bad drawing of a Raspberry Pi. and we're going to take that into the GPIO. So this particular input, this is general purpose input and output. So we're going to connect these pins up, and these are going to, this is something else, but we're going to hook those up to the Raspberry Pi. Now, once we have the actual thing hooked up, we're going to take that and sort of process it. So we're going to write a little program on here, and that is going to say, okay, did you turn? And if you did turn, did you go left? Did you go right? And once we figured out how to decode all that, we're going to take that and we're going to go over a magical technology called Wi-Fi. And we're going to hook that up to the computer that I'm broadcasting to you on right now on a web server. So we're going to take this web server. So after we have this, we're going to decode stuff. Then we're going to hook this thing up to a very simple web app. And that's going to report where we are on the actual knob as we're turning it around. And when we're done with that, we're going to build a very, very simple UI, which is going to show us where that knob is at any given point. So for this, we're just going to be doing kind of standard stuff. We're going to be using Flask, and we're going to use the single thread version because I don't really want to muck up this example too much. So you can properly use this in a data store. I don't know. You can have fun over there, and then you can hook a few of them up, and then you can do all sorts of other magical stuff that you do when you're in the cloud. But we're going to skip all that today. We're just going to focus on taking this encoder, hook it up, send it over to the Pi program, send that over across there over to this website to say this is the dial has changed, and then we're going to hook that up to a web browser. So this is that's the plan. All right. If you have questions about that, just throw it in chat, and I'll kind of get to it as we can. Now, all of that magic aside, let's come back over here. So this is kind of how we normally operate on this stream, but today we're going to be doing something a little bit different. I have up here the pinout. This is one of my favorite websites. This is pinout.xyz. So just in case you forget what pin is what, and they're numbered all sorts of crazy different ways on a Raspberry Pi, you can go to pinout.xyz and you can see what you're hooking up to what. So this is really good when I'm wiring things. I'm always like, which pin did I put that on? Where is that input? All that stuff. Now we're going to have a little bit more fun today because that's just not enough. So we're going to hook this thing up to a microscope, except it's in macro mode right now. So this is actually our live Raspberry Pi. It is powered on. I've not done much else with it other than configure it to be on the same network that we're going to be operating on. And we have this row over here. These are the GPIOs. So we're going to plug these two wires. They're just not connected. We're not using them today. So that was from some other bad soldering. I am not the best person in the world at soldering. And these pins over here, this is what we're going to be hooking up to the actual rotary encoder. So this is the rotary encoder we're going to use. And it's one of the 5-pin versions. So these first 2 pins, they're not very interesting. This is ground and this is V+. And they're really only there just to make sure that when we start reading this stuff, 0 is kind of normally 0. So if the encoder's not doing anything, it's saying like, okay, this is 0. Nothing special happening here. These 3 pins are kind of the interesting part. This one here, the gray wire in the middle, which let me get that better in the shot. So this gray wire over here, this is just a switch. So if I actually push this guy, then I read it off just by checking out this switch. So we're going to kind of ignore that. It's not really about encoders today. Yes, you are absolutely right, Nightshade, dude. I should really just get over that. I mean, it is definitely a blackboard, but it doesn't have like the really annoying screeches and all the other fun that goes with an actual black chalkboard. Okay, so you have this gray wire. We're going to ignore that. And then these two values are kind of the ones that you really need to deal with, this red one and this blue one. And that is typically it's called A and B. So this we're gonna call this the A side. We're gonna call that the B side. On this particular switch, it's labeled as clock and DT. I'm guessing data, but it's not really a clock. You don't actually clock this thing out. So it's really just think of it as A and B. It doesn't really matter. So there is one more thing that I want to talk about before we actually dive into code. So let me just equip the writing glove for a moment and go back to Nightshade Dude's Blackboard, which is much better named for what it is. And we're just going to throw this out for a moment. So over here we, since we want to kind of switch this up a little bit, let's be yellow people. Okay. So the way this actually encodes is we have this A line and we have this B line, and if you want to imagine this sort of physically, it has a in there is actually a kind of like a strip. So if you imagine this strip, let me fill this out a little bit more. So in this strip of tape, then there are areas which are going to be black and there are areas that are going to be white. So, or in this case, they're going to be yellow and they're going to be black. But we're going to put these things at regular intervals and we're going to offset A and B by 90 degrees. So they're going to be 90 degrees out of phase. So wherever this guy starts up, a little turn later, this is going to be starting up. And that's where this strip is going to be. And then we're going to have a nice little gap so that we know that there's a zero line, and then this guy is going to be coming over here and this guy is going to be coming over here, and so same story again. And this is kind of important because we're going to need this to be able to read the encoder. So the way that's going to work is imagine that like reading it is sort of like cutting a line straight across. Okay, so if I cut the line straight across here and I pretend that whenever I'm on this black cube, I have a 1. And so these black values are 1s, and that's all great. And these other values over here, we want that back. These other values over here, we're gonna call them hot pink. Yeah, we're gonna go with zeros. So whenever I'm in one of these areas, if the sensor's directly over it, I get a 0. And if I'm directly over this black area, I'm going to get a 1. So how does this look if we sort of go down? Like say we're actually turning this thing. And so we're taking this line that we just drew across and we're sort of bringing it down. So at the line point where it is right now, so we have A and B. And actually, let's not confuse our colors. We have A and B, and we're heading in the down direction. So right now at the line where it is, we have kind of a 0. That's a 1 and a 1 because we're just reading across and we're going, okay, you're on the 1, you're on the 1. We come down a little bit until we're just hitting here, and we notice that this is now flipped to 0, and this other side is still 1 because we're still in that black area. Now, as that kind of proceeds, this is going to keep going down. So we eventually hit this point, and then we end up with now they're both 0. And then as we hit this point, now this is going to go back to 1, and this is going to stay on 0. And if I keep going to my next cycle, then this is going to be a 1 and a 1. Now, that's all pretty cool. So I can tell that this is going this direction because I'm just going to be looking at what these inputs are. Now, let's do the same thing in reverse. So assuming that we start at this same line, we're going to start off with our 1, 1. So we don't really know anything. But this time, this is going to stay 1 and this is going to turn 0. So we're going to get B going 0 first. And then as we move up, we're going to move them both to 0. And then B is going to move off into the 1, but A is going to stay 0. And then eventually, we're going to come back to the next cycle where we're sort of up here and there's just both 1s. Okay, we can see this is different from this. So I can tell that if I'm reading A and B, I'm going down if I'm seeing this stuff, and I'm going up if I see it in this order. So all I have to do is just watch A and B sort of relative to each other, and then I can read this thing. So that's important. I'm going to leave that up for myself so that I get the code right. But that's important for how we're going to actually decode the hardware. So I've got this wired up for you, and thank God you don't need to watch me soldering. But this, these pins here, these first two, this corresponds to, this is why I have this highlighted. This is BCM 17 and BCM 27. By the way, Nightshade Dude, if you get a chance, let me know, how's the mic sounding? Is this better than last week? Or, I mean, the other one was kind of fuzzy. So I've got that plugged into BCM 17 and BCM 27, and that's hooked up to over here on the encoder. That's our A and our B. So as long as we're just reading those lines, we should be all right. All of these other wires, you just don't have to worry about. I mean, it's basically just power and ground and boring stuff, and the switch in case we feel like playing with the button. All right, so without further ado, let's get to some code. Okay, so this time we're not really going to be coding too much on this particular machine because we're going to be going over to the Raspberry Pi. So let's just jump over there, and with a little bit of luck, yep, we're good. So yes, this is the inception version of coding with some guy. This is screens within screens within screens. So I'm just going to label this real fast so that you know that I'm sitting on the Pi when we're on this window. Okay, and then we're also going to need, maybe I'm being optimistic, but we're going to need the stuff for the web server. So let's make a nice episode 3 directory for us to work in, and this is where we're gonna work on web stuff. Okay, so great. Oh, thanks, Nightshade Dude. That's good. Nice improvement over last week. Okay, so don't read that. There are things there you just shouldn't see. We'll get to inertial forces later. So here I've just started this directory, and there should be nothing in it. Good, I'm a good person. Okay, so let's get coding. Now I don't have any of my little helper scripts on here, so we're just gonna code this the old-fashioned way, which is we're just gonna edit the file starting from the beginning. All right, so let's call this Rotary Encoder. That looks like something I don't like. That's regular, so we're gonna call it RotEnc. Okay, so to get this started, we're gonna need the GPIO function. So this allows us to access that this board over here. This corresponds to those pins that you're seeing over here. Isn't that nice? See, if I turn this, then they actually line up the right. Well, yeah. Okay, then they actually line up exactly the same as they are in that pinout, which is cool. And what we're interested in is this 17 and this 27. So we're gonna try to remember that. So let's say that this is pin. I don't know, what do you want to call this? I've been naming it the same as the what's on the board, which is the clock. So let's stay with that. So pin clock is going to be 17. I'm going to use these BCM numbers instead of using the actual pin number. And the data line is 27. Okay, so I need to set those up. I need to set up stuff to get going, and we're going to need a main because we need to call our setup stuff for the moment. And let's do a little Python cruft that I have written too long. We don't really need this because we're not going to import it as a module, but let's not let our standards slip. So if we have this set up, then nothing really, just set it up, guy. And we can just make sure that we're good. Now, okay, let's go to apps and S1E3. All right, so we have this thing. The Python install, this is based on Raspbian, already has GPIO in the system, so you don't have to worry about that. So let's just run our trivial thing, and yeah, it's just not going to do much at all. Okay, so it's telling us to get set up. All right, so the first thing we have to do is say, are we going to use, so this BCM, I'm guessing this stands for Broadcom because Broadcom made the main chip that's in the Pi. And these correspond to kind of, I'm guessing, the wires that are actually on the die for the chip. So that's going to be what the system thinks of the pins. These are just actually, these pins are where these numbers that are very hard to read are where it's tied to on the circuit board, based on the circuit board design. So using this is more logical, using this is more physical. It doesn't really matter which one you use, but make sure that you're using the right numbers for whatever you're programming. Okay, so we want to say like, well, we're not going to set this up. We're just going to do it. We want to put the board into the right mode. So let's set it for, we don't want board mode. We want, what is that called? I always forget. Oh, it's BCM mode, isn't it? not very interesting, except it's capital. So that's, now we're going to use the 17 and the 27, and we have to set both of these up for input. So we want to make sure that when we're actually on the clock pin, it's set for going in. We're not going to be driving a load out on the circuit. And we're going to do the same thing for the data pin. Okay, so both of these are set up, so we're able to read them now. So that means that this program should visibly do nothing, but if I was watching the circuits over there, then we would have just seen the state change on the Pi module. Okay, let me put my star here in the shot because it just doesn't want to be there. Okay. Great. Well, what do we do? Well, now that we have these things opened up and we're ready to start our action, let's let that happen. We're also going to bring in just optimistically. Well, no, let's not do that. So let's try reading one of these pins. All right. So if we actually read both of these pins, then well, I'll do one at a time. So we want to take the GPIO input on the clock pin, and we're going to assign it to clock. And we're going to do the same thing with the data pin, except that's capitals because it's a constant. And then we're going to print both of these out. So that's going to tell us what clock and data are right this second. Okay, great. It was ready, and then it was 1, 1. Now, that means that it's sitting on that area that I showed you before where, it's kind of in its like 0 state. So the rotary encoder is not turning. It's going to sit on 1 until it moves over one of those other patches, at which point it goes to 0, and then it's going to switch to 1. What order they're in is kind of what's important. Okay, so if we read them infinitely, if we just say, all right, just keep on reading them forever, then I can actually just put that in a loop. And yep, there they go. Now, if I go over here and I start turning this encoder, then you won't be able to see it probably because it's really, really fast, but some of those numbers are blurring because we're actually getting the zeros. Cool. All right, we have some input. Now we need to take that input and we need to decode it. So we're going to use a little trick with rotary encoder. This is one of those things where you can just write like all sorts of crazy code if you want, but the easy way to do it, and I like easy, is we are going to take the, we're going to take clock switching. So right now it's 1, so it's logic high. We're going to say when that thing falls to 0, that's where I want to read. So I'm not really interested in this until clock drops down to 0. So we're not going to read this directly. All right, so we're going to stop that little program. Instead, we're going to say, all right, GPIO wait for edge. So we're going to wait for either it's going to go up or down. And it's already up, so we're waiting for it to go down. So we're going to wait for edge on pin clock to be falling. So that means I want the exact moment. I want this program to stop everything until it sees that change from 1 to 0. and then it's going to report it back to me. Now, I know at that point that the clock is now 0, so that's fun. And if I go and I check that, then, all right, so this program should spit out 0 as soon as it notices a change. So you notice right now it is looping, but it's just waiting for me to do some input. So if I turn it, yep, there's my 0. Okay, so I'm going to get a 0 either way that I turn it, because it really matters what's going on with the other pin. So now you'll notice it blocks until I give it another input. All right, great. So what I want to do here in a very tight loop is I want to say, okay, so here we know that the edge came in. So we know that the clock has just gone to 0. So now we want to watch for data. So we want to know when the wheel turned far enough that data actually did a thing. So let's, we're just going to say, but we're going to wait a full cycle. So rather than, like we could say like, okay, the moment data goes, but data's going to bounce because switches are a little bit messy. And of course they don't, the values jump all over the place. So, instead, what we're going to do is we're going to take, we're just going to keep watching clock, because clock is now low. All right, so it's chilling low, and we're going to wait until it goes back up. Except this time we're going to keep reading data because we want the last number that was on data right before the clock went back up. So to get that coded, I need to basically just sit here pounding on, and by the way, there's a lot of ways to do this, and this is just, I think, the simplest to see. I'm just going to keep pounding on this input until it's 1 again. So actually it's, this is, it's going to be sitting on 0. So as long as it's not 1. So we're just going to keep on reading it until it hits 1. And when it hits 1, we know that we've transitioned out of that loop. And while we're doing that, we're just going to keep resetting data with whatever the latest value is from data. Great. Now when I get down here, clock is now, I know that clock is flipped back up to 1 because that's what terminated the loop. So clock is now 1. So if I print this out, I'm going to see, okay, it's ready, and we're good to go. We start turning it. There it is. And you'll notice when I turn it to the left, I'm getting a 1 on data. Now clock's always going to be 1 because that's the end of the read that I'm doing. But when I turn it to the right, magic, it's a 0. So we read that encoding off it, and now we know based on the moment that we're reading it that this data pin basically tells us which way we're going. So I'm going to stop that. And because it's a lot of fun, now we're going to do something with it, because we didn't just sit around reading all those pins and just to see that the encoder works. We know the encoder works. Okay, so instead, now that we're here, we don't really care about clock anymore. We do care about data, and that's probably the reason they named it that. Because if I read it at that point, then that's going to tell me a 0 whenever it is going to the left, and a 1 whenever it's going to the right. So let's do something with it. What are we going to do? Well, let's say that our delta, which is currently 0. So if I'm going to go to the left, then I'm going to say delta is -1. If I'm going to go to the right, then delta is going to be +1. All right, so if data is 0, then delta is going to be -1. I'm just going to write this out the long way because I don't want to do any fancy code. Otherwise, I mean, there isn't another case. Data is going to be 1, but so let's just say otherwise, well, just to be code complete, if data is 1, then delta is going to get a 1. All right, so if I do this and I print out delta, delta should now be telling me -1 if I'm going left, +1 if I'm going right. Great, let's try it. Okay, now you'll notice a little switch bounce in there. I got a few turns, even though I was just turning it to the left. And I'm turning to the right, and of course I've got my logic reversed. I now have it, it's -1 if it's going to the right. So let's change that because our volume should work the way people think it works. Okay, so this will be +1 and this will be -1. All right, so if we do that, then yeah. Okay, so there's our -1 and there's our +1. Great. Part 1 done. Ship it. We're done. We've built a nice little digital decoder on our rotary encoder. All right. We didn't really want to just write out 1 or -1. We want to go and do something with it. In fact, we're going to want to make a web request. So I'm going to use the requests API because it's fairly simple. But before we actually make a web request, whenever this knob turns, we need to have a web server. So someone's got to be sitting around to actually receive the results of this thing. So here we get to use our fancy tools. All right, great. So I'm calling this dial because this is, it's not a Python app. It's actually going to be a Flask app. So we can make a nice little simple, and that's going to tell me I need the name. So we're going to call this dial. All right, great. We have a little web app, and we can come in here and fire this up. So I'm going to edit the code in this window. So let me just come back here. This will be our, I'll label this, this is our server. So here I'm just going to run in the virtual environment, the main. Yeah, okay. Now, what does this application do? Well, it's got my boilerplate code. So there's not much. It's just telling me to edit the template. Great. Okay. So let's edit the template. Before we get to the template, I'm going to put this back up here because I like this. Let's go and edit our program. So to do something. So I'm not going to do anything on the home page yet. Instead, I'm going to work, and I'm not going to be taking post input here, so we're not going to need that. But I'm going to make another endpoint, which is where the pi is going to hit, and it's going to say, okay, we just went up or we went down. Hey, what's up, High Cures? How are you? I could use some High Cures. Mana's low. No, mana's fine. All right, so let's. Oh, but coffee's low, so let's. I was feeling very. I was taunting an astrophysicist the other night, so I decided to theme today on Arecibo Observatory, which is really cool to see if you ever get a chance to check it out. And it was not destroyed in the earthquakes in Puerto Rico, so it's still there for you. This is going to be the dial endpoint, and actually it doesn't have one of those, so we're just going to do this. We're going to say, okay, when you hit dial, come here, and let's just return, let's return 0, because except you can't use a number, so we'll just return 0 for the moment. So cool thing about Flask, it auto reloads. So if I go and I hit this page, I've now got a dial endpoint, and it's returning 0. Great. So I'm going to add a parameter, which is going to be the value that is going to come in. So let's do, that's on the request. So it's get args. We're going to call this the v parameter. Actually, it's not get args, it's just args. Yeah, because it's just an array. Sorry, I was looking at some Java earlier today. So all right, so this will be our v parameter. So let's actually test to make sure that's there, because we're not really sure yet. So if v is in request args, then we're going to read the v parameter, and we're going to just very simply convert it to a number, which should throw if I pass it a string and I forget to send the right value. So if I can't turn it into a number, then puke all over the website. Oh, that's that. Yeah, I know that feeling. And on a Friday, it's very hard to catch up on the weekly goals. I used to sit next to where the board game people, the tabletop group, would meet at Netflix, and they had tabletop nights on Thursdays. And basically, every time I saw them starting to collect, like George or some of the others, like drop by, I would be like, oh no, it's Thursday. I'm not done with the stuff for the week. So I live in fear of board games, even though I actually really like them. Okay, so let's just convert that up, and actually I can just, let's do it all at once. So this is fine as long as the number that I pass to it is really a number. So if v is like 10, we're all right, but if v is high cures, because high cures, then we get all sorts of garbage and everything breaks. So the key thing here is that sorry, the non-pun version of this, the important part of this is that I get thrown a value error if this thing can't be turned into an integer. So let's just catch that. So we're going to say unless you get, try this, unless you get a value error, in which case I don't care. We're just not going to do anything. So this tells us to kind of quietly disregard it. So if I pass in high cures, okay, it's just going to still returning 0. Okay, so we want to hand in things like 3. All right, fine. There's 3 and it actually works. Okay, if I want to just double check that on the console, I can do this. And, yep, there's my 3. Okay, so we know how to parse input. Now that I've got this control, why don't we make it return? I'm going to go very simple here. I told you before I was not using a database, and technically, since this is a website, I mean, any number of requests could be coming in, any number of users could be coming in. And that's a problem because now I've got a global situation where I have one number which applies to every request. So because I'm not worried about more than me using this right now, and I'm not putting it on chat for you all to hit and break my little demo, I'm going to instead just make a global, which is going to be called value. Let's say dial value. And it's going to start, let's start off in the middle. So let's go 5, I guess. I'm going to scale all the numbers up by 10. So we can always scale them back down. So now that I've got this, I'm going to need to say, well, there's a global, and yeah, I know this doesn't work on a production web server with multiple threads, but you can write this thing out to a store. You can do all the fun stuff of dealing with a global locking increment, but not important for right now. If you do want to hear about that, we can do that in another stream. I know everybody's probably been bit by it at some point. So if I do this thing, then what I'm going to do is I'm just, instead of writing it out, I'm going to adjust the dial value by whatever comes in. So if the dial value, I'm just going to say well, I'll write it out for you. Dial value is dial value plus whatever V is. All right, cool. And for output, I'm going to return the string version of the dial value. Okay, so now I go and I reload this page. I'm at 53 because I passed 3 in. Okay, so if I pass in a -3, I'm back to 50. And if I do it again, then 47. All right, cool. I don't know, High Cures. I may upload this to YouTube. Let's see if it works first. Okay, I don't want to tempt the demo gods. Okay, this is live hardware for y'all. So, all right. But thank you for dropping by. Just in the event you got to run. So now I've got something which will sort of persist the value on this web server, and I see we're running low on mana, so we better move along. Okay, so I've got my actual value over here, and because I feel like dealing with larger numbers, I'm going to say this is delta times 10, and I'm going to, instead of printing it, if delta is not equal to 0, I'm going to actually run a request. Because we're building web servers, right? So we actually want to hit the requests. Now this is going to be a GET request, nothing too fancy. And the server that I'm running, my laptop right now is sitting over here, and we're looking on port 5000. And I know they say don't make it accessible to external hosts, but this is, well, all right. And we're going to hit the dial endpoint, and we're going to pass along the value, which is going to be some number. And that number is held in delta. All right, great. So this will run a web request and totally ignore the result. And let's see. Now, the requests import is actually quite big. That's why it's important that you want to see this ready thing so that you know when to actually turn the knob. But anyway, let's give it a go. See, ready's not coming up. Ready's not, it's not ready. Oh, it's really not ready. Okay, there it is. That's the yeah. When you pull in requests, it pulls in a lot of stuff for a Pi Zero. The Pi Zero doesn't have the fastest processor, but so we're gonna watch on the web server now to see requests coming in. So I'm gonna come over here to our dial and I'm gonna turn it. Oh, look at that! Look at that! There's our numbers coming in. And if I reload it over here without the parameters so that I can see what the number, wow, 70. All right, now I can take this and I can go, well, we don't want 70, we want like 80. All right. Yeah, all right. So great. All that's left is we just have to put this in a UI and we have this volume knob on the internet. So let's whip something up real quick with, ignore the global, sorry. Let's put something over here in this home template. So I'm gonna just actually here, let me split this so you can stay over here. I want to open up this template and there it is. All right, it was telling us that we needed to edit some stuff. Great, we're editing. This is going to be, we're gonna do a little JavaScript. All right. Sorry, Jordan. I was giving him a bit of a hard time about some of this stuff last night. So here we're not going to do too much. Basically, just logic-wise, the idea is we're going to just pull, just like this website over here is showing me the value. Let's just pull the value, and whenever that value comes up, we're going to adjust like the width of an element. So let's make an element to kind of mess with. So I'm using a span because I'm tired of divs. So we're going to call this the dial's an overloaded word. Let's say knob value, knob widget. Okay, and we're going to write proper HTML. So we need to read that. So this is the knob widget is going to be document get element by ID, the knob widget, and we're cool. All right, so we have something that we can play with, and just to make sure that we've kind of got our styling right, let's try setting the let's set it. Let's call it update knob widget. See, writing Python. Okay, so here I'm going to take my knob widget control, and I'm going to be very well. Here, let's make sure we call this thing once, just to do a little. No, I want the semicolon. Let's set the attribute on there. We're just going to mess around with the style. So I'm going to put volume. Let's drop some. Well, let's make it short so that we can see that it's changing. All right, so we're going to set the style on there. We're just going to kind of dynamically manipulate this. So we want to make sure that this is acting as a block element. And I'm going to give it a background color so that we can see what it is. Chat, let me know what color you want. In the meantime, I'm just going to go with teal, but I'll take whatever your recommendations are. We're going to set the width to something. We're going to say the width is 50. All right. So if we do this, we should have gotten nothing because this is the wrong page is why. So I need to look at the home page. Okay, so it's 50. I can change that. I can make it 100. All right. So we do that. Yep. All right. So we're changing our size. Now, because I'm just going to mess around and assume that all browsers implement the things, we're going to do this as a, we need to make this a variable. And let's change this to dial value. Okay, so we're going to set let dial value be 75. All right, so this should be the kind of result we end up getting. And we want to basically just adjust the size based on whatever this dial value is going to be. All right, so we reload it, and yep, cool, it's working. All right, so our job is really just to set dial value at this point. We need to go poll. We're going to use polling. I mean, you could use a WebSocket or whatever, but we're gonna just poll very simply on the server, and every time we hit this update, let's fire off a request. Okay, so we'll use the fetch API. It's pretty widely available these days. And you don't have to deal with the XML stuff. Okay, so we're going to call this the request, and this is going to be a request, and we have to build a request. Where are we going? Well, relative to this server, we're going locally just to hit the dial endpoint, but we don't actually want to set the value to anything. So we're just going to kind of do that so that it says, okay, I'm just going to tell you what the current value is. We don't need any parameters. I mean, there's basically nothing to a get. I mean, you get that method by default. I don't even really, actually, sorry, I'm junking this all up. I can let it do that because it's gonna assume that I'm on the same server that I requested the web page from. So if I have this request, and I'm going to go and I'm going to fetch it, then this is a thenable, so I can then say, all right, and we'll use new syntax. I'm going to get back my request that's built, and what part do I want? I want the, just give me the raw text that comes back. I know that the thing's just going to be a number, but let's get the text, and just to be boring, when we get that text, I'll call it something else. Let's see it on the console. All right, so if that works right, then we should go here, and there it is. The value came back, it was 50. If I check here in the server log, I can see that a dial request came in. If I just reload this, yep, there it is. There's my dial request coming in. So request API for the win. Nice and easy. Okay, so we know that dial's coming back, and it'll have a number, and we're not going to check the input, but you would do that in a real application. So instead, we know that this is basically the dial value, so I don't need this anymore. And this knob widget, I'm just going to set it right here. Whoops. So this'll, and let's just break this line. It's not gonna fit anyway. Hey, look, I can cheat. I can get rid of the spaces. Yeah, that makes it nice and readable. Okay. Oh, just barely. All right. So line games aside, if I reload this page, this now sets it. Now, if I go and wow, that worked. I'm always shocked when like code works. So let's just go and turn this a little bit. So we're gonna turn that. Now we notice it's not updating on the web page. But yeah, it did when I actually reloaded it. So let's throw that. Let's set interval that. Let's just start hitting that endpoint, So every 200 milliseconds, check to see what the value is. So if I reload this, all right, it should be hitting. If I go and I check the server, yeah, it's hitting. Okay, so now if I turn it, there we go. Yeah, there's a little switch bounce in there, and we can come back, and everything just kind of works. Voila, there you go. Knob hooked up. Now, if I want to cheat, because I did tell you that this one was going to go to 11, we could do the math on this dial value that came in. We could take that dial value and we could divide it by 10. And we could say that that is the text widget. Knob text is going to be that, and I can set this attribute, and at the same time I can take this widget and set the inner text of it to knob text. And if I check that out, now I'm getting the number in here. So this is showing us that we went to 24. But there you go. And we have it. This one goes to 11. Thanks everybody for dropping by. I'm going to be doing a live learn session. I'm going to continue on free code. So this will be, this is your kind of prepped, things kind of work. Yeah, because they always work. But I'm running out of mana, so I'm going to go and grab lunch. And I'll be back on streaming in about half an hour. So, you know, let's see, what do we got? It's about 2 now. Yeah, 2:30. All right, cool. I hope you enjoyed it. And please, if you're around, sign up for the Discord. I'll go find that someday because it's yeah. Let's find it together. It's twitch.tv. Oh, we're gonna see ourselves. Some coding guy. Yeah, we can see the lag. Okay, but we're gonna ignore all that, and this is kind of the thing that you're gonna want. So I'm just gonna drop that in chat, and I got too many rules in there, and we're good. Okay, but we're gonna ignore all cool. That. So inception aside, have a nice day, and I'll probably see some of you in half an hour for some Godot GD script. We're gonna continue on the game that I started at LuxJam. So see you later. Probably see some of you in half an hour for some Godot GD script. We're going to continue on the game that I started at